Hello everybody, this is Solar Tiger with another solar power video. Today is the first really sunny day of 2017. It is the 2nd of April and outside it has been very sunny all day long. We have done some work in the garden and that's outside. It's very sunny. Outside there are 3 100-watt solar panels on the roof of my shed that you can see the white border for. That's the white line on the top of the shed. They're wired in series as I have a MPPT solar charge controller. This is the EP-ever Tracer 3215BN MPPT charge controller. This is the 30 amp version and you can plug in a remote meter, the MT50, which you've seen me using before, but at the moment you can see that the display is blank. That's because it's not plugged in. I have the controller plugged into my laptop. So how you do this is you buy a USB to RS 548 converter, and then I just use some cheap network cable, and the controller has an RJ45 socket on the front, so that is that. Yep, the RS485. So you can connect it to your laptop and you can monitor your solar charge controller. So this is the EP-ever solar station monitor software, and I have it linked to my Tracer charge controller. So you can see that the current coming in from the solar panels is 2.45 amps and the voltage is 47.92. Apologise for the loud noise in the background. That's my power inverter, which is actually powering my laptop, and we have a power of 117.87 watts coming in at the moment. Then we go on to the battery voltage. The battery's bank is at 13.76 and the charging current is 8.29 amps. So as it demonstrating the MPPT, we have 2.44 amps at 47.92 volts going in, and we have 13.76 volts at 8.2 amps coming out. The minimum voltage of the battery bank today was 12.41 volts and the maximum was 14.96. That voltage is high because I have AGM batteries, and the label on the batteries states a charging voltage of up to 15 volts, but that's because I have AGM batteries. If you have other types of sealed lead acid batteries, then you need a lower voltage, but that will be given on the specification sticker that's on your batteries. You should always use the voltage that is stated on your batteries. It is not good to overcharge your batteries, as it will shorten the useful life of your batteries, and batteries are expensive and you want to take care of them. So from the load output of the charge controller we're drawing 180 milliamps and the voltage is the same as the battery, 13.75, and the power of the load is 2.88 watts. I will state now that that is what is being drawn from the load output of the charge controller. I am using a power inverter, a 300 watt pure sine wave power inverter, 12 volt model, and that's wired directly to the battery bank, because at maximum power it draws 30 amps and the charge controller can only supply 20 amps from the load output, and I did say it was a 30 amp controller. it can put 30 amps out to the batteries, but only 20 amps out to the load. So any load that is being run from your inverter means that it will not be shown here. You can see in the background here that I have a NASA BM1 battery monitor, and this shows the total net charge or discharge on my battery bank, and you'll see that it says I'm charging at 3.6 amps even though I am running the power inverter. So this is the difference between the charging current and the current being drawn from the batteries. So this is the net difference. So in this case I am charging my batteries. Now that this says my battery bank is at 13.6 and the tracer says 13.78, I would trust the NASA BM1 more because it is a more expensive device. So that is that. It does say that at 13.78 volts my batteries are 64% charged. That is not true. Anything over 12.6 volts is considered 100% charged. So disregard this. The controller has a battery temperature sensor, and the temperature of the batteries is 20.48 degrees Celsius, and the controller itself is at 27.78 degrees Celsius. And it states that there's a solar coming in. The controller is in boost charge mode, there is no fault with the battery, and that the DC load is on. Okay, coming down we have some energy production figures. This is for energy production, that is i.e. from the solar. So today we have produced 0.91 kilowatt hours, that's the highest ever. This month I produced 1.1 kilowatt hours. This year I have produced 15 kilowatt hours and an all-time total of 55.48. The energy consumed here is only the DC load. So anytime I run the power inverter, this messes up these figures because the controller doesn't know about any load that is wired directly to the batteries. So that's how that works. Okay, coming to the real-time curve as shown on the screen. This is the power curve. The red line represents the solar panels and the blue line represents the DC load, i.e. not the inverter. So what you can see here is that we have 50 watts, 100, 150, 200 watts. That is the power coming in. I apologise for my sniffling, I do have a cold. So what you can see here is that for the majority of the day the input power has varied between approximately 50 watts and nearly 200 watts. So that is a good day. Now I will say that I have run the inverter pretty much all day, running my laptop and the power drill charger since I used it today, and I charged the electric bike battery. Since I have good weather and lots of power coming in, I thought I would charge up my equipment. So you take advantage of the weather. I normally do my charging of devices mainly on Sunday. That's the bigger things I charge on a Sunday during the daylight hours when there's sun. So that is the real-time power. If I go to the current one, you'll see that this is the current curve. The red line is the current coming from the solar panels, and the green line is the current going into the batteries. Now, as you can see, this is an MPPT controller, so we have low current at high voltage coming in, and we have low voltage and high current going out to the batteries. That is the DC to DC conversion performed by the charge controller. And you can see today that I've been doing well. I've had a lot of the time the current's been over 12 amps. There were a few blips when the clouds came over, but on the whole this has been a good solar day. So I have 300 watts of solar panels. They are three 12 volt, so-called 12 volt panels wired in series, so I can see a voltage in excess of 660 volts on a very good day. So this is the EP-Ever software. Now the only thing about this is that from what I can work out, it can only monitor the device. I can only produce this curve with the laptop connected to the solar charge controller, and while I want to monitor it, I have to leave the laptop connected to the charge controller. I've had the laptop on all day. In order to do this, I don't see any other way that I can download the data from the charge controller. I've not seen any way of doing that. So this is Solar Tiger with another solar power video. Now that the weather has improved a lot, I might be producing more solar power videos. So this is Solar Tiger saying thank you for watching. I will just say that this laptop is a Dell XPS 17. It's a desktop replacement laptop, so it's fairly powerful, and running it on the inverter, it uses about approximately 100 watts when it's working, so that's a good load for the inverter. And basically what normally happens is the batteries top off and then the controller throttles down the charge to stop the batteries overcharging. So if I want to see what sort of potential my solar panels have, I've got to place a load on the charge controller to stop it reaching the float mode. So that's how I've run the laptop all day, and my target today is to reach 1 kilowatt hour, which I have never done before in my time with a solar power system. So I'm on 0.92 at the moment, and I think that I should be able to reach 1 kilowatt hour today. So this is Solar Tiger saying thank you for watching, and until next time, goodbye. Thank you.